When you buy a new home, you see the beautiful paint, the shiny countertops, and the fancy light fixtures. But what you can't see is what matters most. I'm talking about the bones of your house, the concrete foundation and the wood frame. These two systems are the most critical parts of your home's structure. They hold everything up. If the foundation isn't right, you'll see problems everywhere, from cracked drywall to doors that won't close. A weak frame can compromise the safety and stability of the entire building, putting your family at risk. You have to start with a strong base if you want a home that lasts. Think of it like this: your house is a complete system. Every part has to work with every other part. The foundation supports the frame supports the roof, and the roof keeps everything dry. If there's a problem at the very bottom, it's going to travel all the way to the top. In the Bay Area, this is even more important because of the constant threat of earthquakes. A properly built foundation and frame are your first line of defense against seismic activity. They are designed to move and flex, absorbing the energy from an earthquake to keep your house standing. An inspection makes sure these critical components were built to do their job. Many homeowners assume that because a house is new, it must be perfect. They think the builder did everything right and the city inspectors caught any mistakes. Let me tell you, that's not always the case. I've seen it all. Builders can cut corners to save money, and city inspectors are often overworked. They might only spend a few minutes on site and can miss important details. It's up to you, the homeowner, to make sure your investment is protected. You need to be your own advocate. Getting a professional, independent home inspection of the foundation and frame is not an option, it's a necessity. If you want to know exactly what's required, check the California Building Code, or CBC. For foundation requirements, look at CBC Chapter 18, which covers soils and foundations. For wood framing, see CBC Chapter 23. You can find the full code online at the California Building Standards Commission website, or ask your inspector to reference these chapters for your specific project. When inspecting the framing, pay close attention to the type and placement of nails. The CBC specifies nailing patterns for different framing members, like how many nails per stud and where they should be placed. Look for proper use of framing nails, not just staples or finish nails, and make sure metal connectors and straps are installed where required. Also, check the quality and type of wood used. The framing lumber should be straight, free of large knots, and rated for structural use. Look for grade stamps on the wood. Avoid wood with splits, warping, or signs of moisture damage. It gives you peace of mind and protects your biggest asset. Ultimately, inspecting the slab and frame is about ensuring your family's long-term safety and financial security. A small issue found early can be fixed relatively easily. But if a foundation problem is discovered years later, the repairs can be incredibly expensive and disruptive. You could be looking at tens of thousands of dollars to fix something that should have been done right from the start. Don't wait for the problems to show up. Be proactive. Get in there before the drywall goes up and check that the work was done to code and to a high standard of quality. You have to make it right from the ground up. Before any concrete is poured, you have to understand the ground it's sitting on. In the Bay Area, you'll find a wide variety of soil types. Expansive clay is very common. This type of soil acts like a sponge. It swells when it gets wet and shrinks when it dries. This movement can put a lot of stress on a foundation, causing it to heave and crack. You'll also find sandy soils near the coast and loamy soils in other areas. Each type behaves differently, so the foundation has to be designed specifically for the soil at your property. A good builder will have a soils report from a geotechnical engineer that explains exactly what's under your home. Because of these soil conditions, you can't just use one-size-fits-all foundation. The type of concrete slab must match the soil. For stable, well-drained soils, a standard slab-on-grade foundation might be fine. This is a single layer of concrete poured directly on the ground. However, on expansive clay soils, a post-tension slab is a much better choice. This type of slab has steel cables running through it that are tightened after the concrete cures. This process compresses the concrete, making it much stronger and more resistant to cracking from soil movement. For sloped lots or very unstable soil, a pier and beam foundation is often used, where the house is elevated on concrete piers that go deep into the ground. To ensure everything is built safely, the Bay Area follows strict building codes. The primary one is the California Building Code, which is updated regularly. The CBC includes special requirements for seismic safety found in Chapter 16. These rules dictate how foundations must be tied to the frame, and how the frame must be braced to withstand earthquakes. For example, codes specify the size and spacing of anchor bolts that connect the wood framing to the concrete. They also require specific metal connectors like hold-downs and straps to create a continuous load path that transfers seismic forces from the roof down to the foundation. Don't just trust that the builder is following these codes. You or your inspector should verify it. Ask to see the approved plans and the soils report. Check that the foundation design on the plans matches the soil type described in the report. Look for notes about seismic requirements. These documents are your roadmap to a well-built house. Understanding a little about the local soil, the right slab type for that soil, and the codes that govern construction will empower you to ask the right questions and spot potential issues before they get covered up by walls and floors. It's all about making sure the job is done right. Once the concrete slab is poured and cured, it's time to put on your inspector hat. You don't need to be an expert to spot some of the most common problems. The first thing to look for is cracks. Small hairline shrinkage cracks are normal as concrete cures, but you should be wary of larger structural cracks. Look for cracks that are wider than a credit card, run from one side of the slab to the other, or have one side that is higher than the other. These could indicate serious issues with the soil, the concrete mix, or the way it was poured. Pay close attention to corners and areas where pipes come through the slab. Next, check if the slab is level. An unlevel floor can cause all sorts of problems later on. You can do a simple check yourself with a long level or even a marble. Place the marble on the floor in different spots and see if it rolls. If it consistently rolls to the same low spot, your slab might not be level. A professional inspector will use more precise tools, but this simple test can give you a good idea if there's an issue. Also, look at the edges of the slab where it meets the exterior walls. The concrete should be a consistent height above the ground, usually around 6 to 8 inches, to prevent moisture from wicking up from the soil. Moisture is the enemy of any home, and it often starts at the foundation. Look for signs of moisture on the surface of the slab. Are there dark, damp spots? Is there any white, chalky powder on the surface? That's called efflorescence, and it's a sign that water is migrating up through the concrete. A properly installed slab should have a vapor barrier, which is a thick plastic sheet, underneath it to block this moisture. You won't be able to see the barrier after the concrete is poured, but signs of moisture on top of the slab are a huge red flag that it might be missing or was damaged during construction. Finally, you want to see evidence of proper reinforcement. Before the concrete is poured, a grid of steel bars called rebar or a wire mesh is laid down. For post-tension slabs, a grid of sheathed steel cables is used. This reinforcement is what gives the concrete its tensile strength. Look at the edges of the slab and around any plumbing rough-ins. You should be able to see the anchor bolts that will hold the wood frame to the foundation. Make sure they are spaced correctly, according to the plans, are not loose, and are not too close to the edge of the concrete. These bolts are critical for the home's seismic safety. After the foundation is done, the framing goes up. This is the skeleton of your house, and it needs to be strong and straight. Walk through the house before the insulation and drywall are installed. This is your only chance to see the bones of the structure. Stand back and look down long walls. Are they straight, or do you see bows or waves? Use a 4-foot or 6-foot level to check key walls and door openings for plumb, meaning they are perfectly vertical. A little bit of imperfection is acceptable, but if walls are noticeably crooked, it can lead to problems with installing cabinets, countertops, and trim. It's a sign of poor craftsmanship. Next, get up close and look at the connections. The strength of the frame is in how it's all tied together. Look at the wood itself. Are there large cracks or massive knots in critical studs or beams? Some knots are fine, but a large one can create a weak spot. Check the metal connectors that tie the frame together. Look for joist hangers, straps, and seismic hold-downs, especially where floors connect to walls and where the walls connect to the foundation. Every hanger should be filled with the proper nails. I've seen crews use just a few nails when the hanger requires 10. This is a major safety issue that compromises the entire structure. Pay attention to the nailing patterns. Building codes are very specific about the size and spacing of nails used to connect different framing members. For example, the sheathing on the exterior walls, which is usually plywood or OSB, is a critical part of the home's shear strength against wind and earthquakes. The nails holding it in place must be spaced correctly along the edges and in the middle of the panel. Look for shiners, which are nails that miss the stud completely. Too many of these indicate sloppy work and a weaker wall. The builder should have gone back and fixed these mistakes. If you find any of these issues, document them immediately. Take pictures and make a detailed list. Your first step should be to talk to the site supervisor. Show them your concerns and ask how they plan to fix them. If you don't get a satisfactory response, it's time to hire a professional. An independent home inspector or a structural engineer can provide a formal report. This report gives you leverage with the builder. If you find serious problems, you may need to involve a lawyer. Don't be afraid to stand up for your investment. You are paying for a safe, well-built home, and you deserve to get one. Make it right.